Each time we extend a set of numbers because we have a problem with the preceding one. So far, we don't have any trouble with the set of real numbers. So you can solve the equation x squared plus 1 is equal to 0. What's wrong with you? Of course, yes. Moving 1 to the other side and getting x squared is equal to negative 1. And then taking the square root of negative 1, right? You're not able to get the square root of negative 1, man. And that's why we need a bigger set of numbers. And that we will discuss today. Stick around and keep watching. When you have an equation, x squared plus 1 is equal to 0, and when you solve this equation, you get x squared is equal to negative 1, but you're not able to get the square root of negative 1 because it doesn't belong to the real numbers. So let's imagine that I squared is equal to negative 1, and that is the imaginary number. So the imaginary numbers, when I say I is equal to, or I squared, or I cubed, or I to the power of 4. Let's start with I to the power of 1. I to the power of 1, of course, is equal to I, and I to the power of 2 is equal to negative 1 according to the equation up. What if we need I to the power of a number other than 2, or more than 2? Like I to the power of 3. I to the power of 3, let's break it up. 3, you can write it down as 2 plus 1. So I to the power of 3 is equal to I to the power of 2 plus 1. Just remember, the rule is a to the power of m plus n is equal to a to the power of m multiplied by a to the power of n. So the plus is converted to multiplication. But you already have I to the power of 2, which is negative 1, multiplied by I, which is negative I. So I to the power of 3 is equal to negative I. Let's find I to the power of 4. I to the power of 4, you can break it up like 2 plus 2, which is I to the power of 2 multiplied by I to the power of 2. And I to the power of 2, of course, we have I to the power of 2 is equal to negative 1. So it's equal to negative 1 multiplied by negative 1, which is 1. So I to the power of 4 is equal to 1. What if we need I to the power of 5? Yeah, I to the power of 5 is equal to, yeah, that's right. 5 means 4 plus 1. So it's equal to I to the power of 4 multiplied by I. But what is the value of I to the power of 4? Yeah, that's right. I to the power of 4 is equal to 1. So 1 multiplied by I, which is I. So I to the power of 5 is equal to I. Now, let's find I to the power of 6. 6, you can break it up like 4 plus 2. So it's equal to I to the power of 4 multiplied by I to the power of 2. And you already have I to the power of 4, which is 1. So 1 multiplied by, and I to the power of 2 is negative 1. So 1 times negative 1 is equal to negative 1, and so on. You'll notice that I to the power of 1 and I to the power of 2, I to the power of 3, I to the power of 4, they are all repeated. So there is no need to break it up all the numbers. You can just get the multiple of 4. When you have a number more than 4 or more than 6 or more than 7 or whatever the number, you can break it up like we did, or you can get the highest multiple of 4, but under the value or under the power that you have in the example. Let's take an example and I will show you how to solve this. Simplify I to the power of 24. You know that 24 is a multiple of 4 because 24 is equal to 4 times 6. So you can write down as I to the power of 4 multiplied by 6. The rule is a to the power of m multiplied by n is equal to a to the power of m all to the power of n. So according to that rule, you can write it down as I to the power of 4 all to the power of 6. And you already know I to the power of 4, which is 1. So it's 1 all to the power of 6, which is equal to 1. Another example, if you have I to the power of 26, you know that the highest multiple of 4, but under 26, is 24. So you can write it down as 24 plus 2. You can break it up as 24 plus 2, which is I to the power of 24 multiplied by I to the power of 2. You know the rule, of course. Now, I to the power 24 is equal to I to the power 4 all to the power of 6 multiplied by I to the power of 2. I to the power of 4 is 1, so 1 to the power of 6 multiplied by, and I to the power of 2 is equal to negative 1. So it's equal to 1 multiplied by negative 1, which is equal to negative 1. Simplify I to the power of negative 30. The rule is, if you have a to the power of negative m, that means it's equal to 1 over a to the power of m. You change the sign. The sign is negative, here up. It will be positive down. So I to the power of negative 30 is equal to 1 over I to the power of 30. Of course, you have many solutions here. Let's imagine that 1 is equal to, that I to the power of 4 is equal to 1, I to the power of 8 is equal to 1, which are the multiples of 4, 4, 8, 12, and so on. So I to the power of 12 is equal to 1 also. I to the power of 16 is equal to 1 because 16 is a multiple of 4. I to the power of 20 is equal to 1. I to the power of 24 is equal to 1. I to the power of 28 is equal to 1. I to the power of 32 is equal to 1, and so on. All right. So let's imagine that 1 is equal to one of these. You can select I to the power of 32 because it's up or it's more than 30. So replace 1 with 32. I mean with I to the power of 32. So it's equal to I to the power of 32 divided by I to the power of 30. And the rule is when you have the common base, like a to the power of m divided by a to the power of n is equal to a to the power of m minus n. I mean, you will subtract the powers. So it's equal to I to the power of 2, because 32 minus 30 is equal to 2. And I to the power of 2 is equal to negative 1, of course. So I to the power of negative 30 is equal to negative 1. Another solution. I to the power of negative 30 is equal to I, or 1 over I to the power of 30. And if you break it up, you will find 30 is equal to 28 plus 2. That means I to the power of 28 multiplied by I to the power of 2. And because I to the power of 28, or 28 is a multiple of 4, so I to the power of 28 is equal to 1. And I to the power of 2 is equal to negative 1. So it's equal to 1 over 1 times negative 1 is negative 1. And 1 over negative 1 is equal to negative 1, the same answer. Simplify 1 over I to the power of 15. 1 is equal to I to the power of 4, or I to the power of 8, or I to the power of 12, or I to the power of 16, because the power is a multiple of 4. So you can replace 1 with any of these, like I to the power of 16, because 16 is more than 15. So it's better because it will be easy to get the answer easily. So 1 is equal to I to the power of 16, and keep I to the power of 15. So it's equal to I to the power of 16 divided by I to the power of 15, the same base, so you'll subtract the powers. So I to the power of 16 divided by I to the power of 15 is equal to I to the power of 16 minus 15 is 1, so it's equal to I. All right, another solution here, 1 over I to the power of 15, if you break it up, the power, it will be 12 plus 3, because the highest multiple of 4, but under 15 is 12. 12 is a multiple of 4. So it's equal to I to the power of 12 multiplied by I to the power of 3. So it's equal to 1 over I to the power of 12 is equal to 1 because the power is a multiple of 4. And I to the power of 3 is equal to negative I, if you remember the rules. All right, so it's equal to 1 over negative I, because 1 times negative I is equal to negative I. Now you have I in the denominator. To get rid of I in the denominator, you multiply by I up and down. So multiplied by I in the numerator and I in the denominator, you'll get 1 times I is I, and negative I times I is negative I squared. All right, so it's equal to I divided by, and I squared is negative 1, multiplied by negative is equal to 1. So I divided by 1 is equal to I, the same answer. Simplify I to the power 4n plus 40, or 42. You know the rule, a to the power of m plus n is equal to a to the power of m multiplied by a to the power of n. So it's the same here, I to the power of 4n multiplied by I to the power of 42. And 4n is a multiple of 4, because 4n means 4 multiplied by n. So of course it's a multiple of 4. So I to the power of 4n is equal to 1. Any power which is a multiple of 4, so the answer will be 1. So it's 1 multiplied by I to the power of 42, which is 40 plus 2. I mean I to the power of 40 multiplied by I to the power of 2, because 40 is the highest multiple of 4, but under 42. And as long as it's a multiple of 4, so I to the power of 40 is equal to 1. So you have 1 multiplied by 1 multiplied by I to the power of 2, which is negative 1. So 1 times 1 times negative 1 is equal to negative 1. Simplify I to the power of 8n minus 3. And the rule is a to the power of m minus n is equal to a to the power of m divided by a to the power of n. All right. And the same here. So it's equal to I to the power of 8n. And because you have the minus here, so it's divided by I to the power of 3. I to the power of 4n is a multiple of 4 because 8n is equal to 4n times 2, or 4 times 2n. So it's a multiple of 4, so of course it's equal to 1. And I to the power of 3, you remember? I to the power of 3 is equal to negative I. So again here you have 1. You can replace it with I to the power of a multiple of 4. So you can select I to the power of 4. All right. Divided by negative I. So it's equal to negative I to the power of, and 4 minus 1 is equal to 3. So it's equal to negative I to the power of 3. So again, I to the power of 3 is equal to negative I. So you have negative outside the parentheses, and inside the parentheses you have negative I. So it's equal to I, because negative times negative is positive. So the answer is I.